So in this section we're going to start solving radical equations. We've gone through reducing them, simplifying them, different types of radicals, whether it's a square, a cube, a fourth root, fifth root. We've dealt with domains and zeros and stuff like that, and how they differ from other functions. So now what we're going to talk about is how to solve. So for this problem, we're going to do a quick example here. I want to do a basic, intro just to kind of talk about square roots. So for example, if I had the square root of x is equal to 4, we should know that x is going to equal 16, right? We just know that that's what's going to be x because we understand our perfect squares. But if I want to get rid of a square root, you guys have been taught just square it, and that'll get rid of a square root. They cancel each other out. Well, why do they cancel each other out? Because we now know that x, the square root of x, is the same as x to the 1/2. So if we square it, these guys get multiplied, and it turns into 1. And now we have x all by itself with 1 as its exponent. The same idea goes with a cube root. We should know that x is equal to 27, but how do we get rid of it? Well, we would raise it to the third power. The power that's the same as the root cancels the root out. And so x would equal 27. So let's go ahead and go through this problem. And in order to cancel out square root, we square both sides. So I'm going to go ahead and do that. And I'm actually going to, in the first part, I'm just going to cancel out the radical. But in the next part, I want you to see with my work that that square, because everything's in parentheses, that square goes to both the 2 on the outside and the square root of x. And so we got to be careful with those types of situations and remember that the square is going to go to both. If you don't do that, it's going to mess up the balance of the equation. Then we're going to go ahead and just, I'm going to actually just move x to the other side, and I get 5 is equal to 3x. And divide by 3. X is equal to 5/3. You also want to check your solutions, and the reason for that is if I plug this back in and I get a negative underneath the radical, it's a no solution. So we got to be careful with that. Here's our next example, and we have a situation here where I have two radicals that are the same. So notice these guys are the same, and they're set equal to each other. And it falls under the same property as if I have something raised to a power equal to something that's raised to another power. So we can easily just say that x has got to equal 4. It's the same idea because we have the same type of cube roots. We can just say that x minus 5 is equal to x minus 8. And we can go ahead and balance this out. But what happens here, though, is our x's are going to cancel out. So we get 0 is equal to negative 3. Because these two numbers are not equal to each other, this is actually a no solution. So we have to be careful with certain situations. And the same idea is, sometimes we have graphs that don't cross. So if you think about the idea that a solution is where two things cross, this function does not cross this function, and so there's no solution, and that's what we're looking for. So what I'm actually going to do also is the video that's going to be associated with these two examples. I'm going to show you the graphs of these two where we can find the actual solutions, so we can kind of see what happens here. So this is one of the introductory videos on solving with radicals.